your screen from my end.
All right, okay. So um, I just want to get us back to where we started last week, and then we move on from there. So basically, what we're trying to do is we are trying to build a model that analyzes application for loans, and then the model is going to automatically analyze if the person is going to default or not going to default. So from there, we can use the analysis to make our own decision. And then we've established that the kind of problem we're trying to solve there was basically classification problem. Because when we think of problems that we can solve with machine learning algorithms, we classify them into classification tasks, regression tasks, and then clustering tasks. Those are the common three tasks that we have. So when you are trying to predict either someone is going to buy or not buy, all those kind of stuff, let's say if the person is going to show or not going to show up for a meeting, so those are classification problem, and they are binary classification because they are two. There are other types of classification tasks that exist out there, but our focus is going to be on binary classification. And then in the process, we've looked at how to bring the data to Fabric, and then we kind of like use pandas library to um, interrogate or question the data about what it has inside. Then we've done a little bit of that. So today we are going to explore the data fully, and then we're going to train our model and move on. So I'm going to be explaining some of the concepts as we are going on, in case we have someone that is yet to be at that level. So everybody will be um, on, up to point. So first off, for people that might not be here last week, so the first thing we did was that create a workspace. The workspace is having fabric subscription on it. So this is our workspace. I compute a new workspace which is on DP600. So it's just for other stuff. So inside the workspace, if you click on the workspace, we have a lot of things inside. We have our lakehouse, we have our notebook, then we have some sort of experiments when we are trying to run. This one are just something that we'll explain as we move on. So just basically know that immediately you want to start, you create a workspace, you ensure that there is a license and subscription on it for Fabric. Then you create your lakehouse. After creating a lakehouse is a place where you store your data. Then you have a notebook there. So if you bring a notebook or you start from scratch, just attach the notebook to the workspace, to the lakehouse rather. So from there you can start working. So these are our lakehouse. Let's go to our lakehouse and see what we have in our lakehouse. Immediately I load the lakehouse, is showing the icon right here on the left hand side of my screen. You see we have credit risk data sets.csv inside our lakehouse. So this is the data that we are using to do this task. Then I can go back again to my workspace. Then let me try to load the notebook. So I think is this notebook or the other one. So let me open the two of them and then see the one that is recent. So it's coming up. Okay. This one is actually um, oh, this one already collapsed when I was working there. So it was supposed to be a in cells, but it already collapsed. That's why you can see in 19, in 20, all of them are cells like that. So let me try to come to where we are. Let's check the other one. Uh, okay, it's still coming on. Yeah. But madam, can you confirm if my screen is actually changing, not like it's fixed like the other day?
No, it's fine. We can see
Right.
your screen.
All right. Okay. So now let's start with where we are. So I think this one is up to date. Now we have our work space here, and then in the notebook we're starting with I added this layer on it, pip install in blend. So this is for a library for data treatment during when you are trying to balance data sets, but we will see it exactly when we want to use it. So to install a library here, like I said last week, you have to rerun all these things every time you come back. If you don't want to be doing that, you need to install all of this inside an environment. So environment is just somewhere you just import all your libraries that you need and put them there. Anytime you open a new workbook, you don't need to keep install again. But if you don't do that, if you just want to work on it in a flat notebook like this, you have to be rerunning all of these things over and over, which is the reason why I will have to rerun all these cells that we have here now. So I'm trying to run the cells. Immediately I'm trying to run the cell. First thing it will do is that it's going to try to set up a session for me. So it's trying to connect to that session. So that's what we are doing here now. So once it's finished this cell, I will just run every other thing um, on the spot that will be there. So while it's running, let us be checking through our code what we've done last week. So I import time is another module again to track what is going on. So to just make sure that if I want to do anything that involves with the runtime of my experiment here, I will use this to really get it. So I'm recording the time. The first one has been run successfully, 33 seconds. So let me come here now and then run everything from here and below. So import time. Here, this is when we bring our data to the lakehouse. So we already imported our data to the lakehouse here. If you want to add a new lakehouse, you just need to click on these lakehouses and then you add another one. So we already bring the data to the lakehouse, we convert it to pandas. Then from the pandas, we import, I was just trying to import the common modules that we have, NumPy and pandas, because I have the option of using pandas straight or I can leverage on Spark. So just for us to be able to see how those things work at a very low level, that's why we are sticking to pandas. So here we print out the shape of our data to know how many rows, how many columns. We remove duplicates. Then we saw all those things, how they are properly set. And then also we group our data into numerical columns and categorical columns in case we want to use them. Then we have all the columns named that are numerical, the one that are categorical right here on the spot. Then the next thing we do was that we want to actually our exploration started from here. So let me add a markdown on top of the cell and call it data exploration. Okay, so it's still coming up. Okay, so let me put a markdown here. Data exploration actually started from here. So let's go. I don't know why my stuff is really slow today. My network is very slow today. So maximum and minimum age was what we first checked. Really, there's no one size fits all way of how you can start all those things. Exploration is just what everybody is trying to see. There's no one straight way that this is what you first check, this is what you check later. You just go there and see what exactly you want to work with. So we use some functions here to group our data set to understand the minimum, maximum age, the age of people that come for the loan between 20 and 26. We saw they are the highest one, 17,000 plus. So that's how we explored that side. And we concluded that our loan is common around the age of 20 and then up to 46. They are the majority. But older than that, they are not that substantial. So we need to take note of that when we are using our model because that's what our model is going to be working on basically. Then we check the income of those people. We also saw that this is where we stopped last week here, I think this particular place here. So now what we did here was that We write a function again to get the maximum minimum income so that we can know the range. Then after that, we now come to define a function called income group because we want to put them into groups. The same way we did last week, we just bucket it into 0 to 25,000, put them together. People from 25,000 to 50,000, people from 50,000 to 75,000, 75,000 to 100,000. We want to see them. So we also do 10,000 upward. So we saw that a lot of people, a lot of our applicants, their income is ranging between 25,000 to $50,000 or naira. We didn't actually specify the value. So now here, let's try to delete these cells that we just start from coming, is coming up. That we can write all these codes ourselves today. Okay. All right. Okay. So, yep. Okay. I think this one is actually now okay. So now we can write something. Let's try to let's start our work here. Every other thing that is done is not really something that we might actually be bothered about. So let me try to write a markdown here. Orders. So let's put orders here. And then, okay. They want to put orders here. I'll close it up. Yeah. Okay. I'm coming. All right. Okay. So we want to begin the data exploration proper now. What we're going to do is that I believe that everyone already have access to that GitHub repo where we describe all the stuff we have inside the data set, all the rows, all the columns we've explored. So we start with exploration. So while we can write the code here ourselves directly, we can also leverage on Data Wrangler. And Data Wrangler is something here that we can see up here. Is more of like Power Query Editor in Notebook that was developed for us to do more with less code. We don't even need to write a lot of code or no code at all. So we will use the combination of Data Wrangler and code in Python in Pandas to do those things. So now let's try to display our data set and see, let's say display DF. Have we tried to rename those things up here? So let's check. We've renamed it to DF notebook. So I'm coming. Let's rerun it again from here. Okay. So we want to rerun this cells. It's coming. Okay. It's a network that is making it take so much time, and then it's freezing a little bit from my end. So, okay, all right. So I'm running them one after the other to be sure that the other ones down are not interfering. Okay. Okay. So by now, I think we should be up to date on that one now. So let's print our data set now. I want us to see it visually. So display the data frame because we already changed it to df no duplicate. So we want to write a summary is equal to true. Then we run this cell and see the current status of our data. Now it's coming up. Yeah. Now these are the columns in the data set. We see this one to be string, string, string. And then here we can see that there's no minimum value, there's not except the loan interest rate as well as the employee length, the person's employment length. That is the number of years that the applicant has been employed. So we are going to be treating loan interest rates and then employment length. There might be others that you need to work on based on what you see here. So because our data set is a little bit clean. That's why we have less to do with exploration. But regardless of what we have, so let's continue and see exactly what we have. We can be printing range, minimum, and all those things to see exactly how it looks like. But let us, I always advise that we go to Data Wrangler because it's very easy for us to even do to work with. So now let me now come to select my data set, which is DF notebook, this particular one. The rest that you are seeing here was when I was running the cells initially, all of them to the end. They have already given them a variable, but this is where we are now, df no duplicate. So I click on it. As I click on Data Wrangler, I select my data frame that I want to use in Data Wrangler, then it's loading that environment. So in the environment, we'll see what we can do in that environment. One of the reasons why Fabric is very powerful. And I think it's already been developed for VS Code as well. But in Fabric is really, really very helpful. So now it's loading, it's still loading. So let's wait for it. Now, while it's loading, instead of us going to our notebook and be printing a lot of stores, printing how many rows, how many variables are in one column, we can quickly come here and see all those things. We can see here that in this particular home ownership column, we saw missing value 0%. That is, there's no missing data. Distinct value there, it is only for distinct values. That is rent, own, mortgage, and then others. Those are the four values that are there. And we can see the distribution. Rent, people that in our data set, people that are renting, that own their, that are renting apartments, they are 67%. That is, majority of our applicants are living in a rented apartment. Some 24% are on mortgage, only 80% of them owns an apartment. So these are the things that we put into consideration when we are trying to work or when we are trying to use our model majorly. So all of this, before in traditional notebook, you will see a lot of code, a lot of Seaborn code, matplotlib code to generate this kind of chart before they can even come here and do anything. So we can still see that education, medical, we see the distribution as well. These are categorical data and they are very, very clear here. And we can see here, if the person has a default before, yes, no is 81%, 19 it's just people that are saying yes. Now, when we come to numerical data, we can see the distribution is a little bit different. And then we see if we are used with Power BI and then we are using Power Query Editor basically, you will see that this column profile or column distribution is already there. So that's why I said it's more of like Power Query Editor. So we can see the distribution and track it from here. Let's say we were interested in the range. We just check the minimum. The minimum income that we have here is 1,374. Then we can come to the last and see that, okay, people from 480 to 510, they are just one, it's just one person that is earning that amount. We can go on as well to do all those things. So these are the power of Data Wrangler. Let's now focus on data on the column that we are trying to clean up, which is the loan interest rate. So let's come there. This is loan interest rate here. Now, one key thing here is that we should study this distribution. As we are seeing this data set, we are seeing a lot of stuff here. We should be paying attention to the distribution as well because distribution really matters. If our data is being skewed towards one part and we continue to build our model is really going to be biased. That is why some models over there, when you apply it in the Nigerian environment, it doesn't really work well because it has been trained largely based on the lifestyles in that country. So we really need to be careful. And then here we can see the loan interest rate. It said that 465 values are missing here. This is a numerical column. To fill these things, we have different approach, which is one of the things that distinguish data scientists from every other person, good ones. Every other person can just come here and say, let me fill it up with mean or median or whatever. But you really need to put a lot of things into consideration. If it's something that can be done with statistical imputation, that is filling it with mean, median, or mode, you really need to ask and check back if those things are very, very crucial. And then again, if it's something that can be done with statistical imputation, you just need to account for that in your documentation as well. So here, because it's just loan interest rate, and then it's telling us the loan interest rate of the loan that they are trying to apply for. We can just ask the bank or the organization that we are working for and calculate it and say anyone that is around 35,000, what's the interest rate? And we can use it to get the actual figure. But we can't be going through the stress of that one here. Let's just come here and fill it with mean. So that the reason why we are filling it with mean is that by the time we put those figures there, it's not going to change the distribution of our data. All our data is still going to try to maintain that distribution to a very good extent. So to do that, we can write code in pandas, but this is data wrangler. You don't need to do all those things. You can just find it on my left, on the left-hand side here of the screen. I'm looking for find and replace, which is here. So you can see find and replace, you can see format, you can see formula, you can see numeric, all other stuff that you can do. So now let's go to find and replace. Here, I want to do what? I want to fill missing values. If I want to drop it, I would have dropped duplicates, do all those things. So let's fill missing values. What do you want to do there? I said I want to fill it with mean. So it's now generating something for me now. It's trying to load it up. So let's see how it is. So here, let's apply. All right. So I generated a new column now, which you can see now that the interest rate, no value is missing again. I already moved it to mean, and you can see the distribution up here. It didn't really change much, it just spread a little, and then it didn't really have much impact. But if your work is really, let's say something in the medical field, you should be very careful about that. Here, let's look for the second column that has missing value. I think that is person's year of employment. So let's check. The first value that we are seeing here is that people here 0 to 7, a lot of them have 0 to 7 years of employment length. So let's check the last one. Let's check the last variable. Here, this is where something gets tricky. In the last part, we can see before we reach that last part, there were a lot of them from 89 to 91. All of them are count 0000. The reason why we have a lot of 0000 all the way to this place was that our last value was 199 to 126. That's our last value. It can't just jump. This is histogram. It buckets them into some things. So those buckets, that is why we have 14 to 21 0, 21 to 28. Nobody is having that length, employment length. 35 to 42, same thing as well. All of them are not having that, but it wants to get to that last one, which is 119 and 126. There were two people in that range. So we need to check those things. They are exceptionals. So we need to check them and see what exactly is happening. And then if you see these ones as well, you see 26, the age is not all also, we have age from 24 to 26 stopping here. And then we have a lot of them again being 00. But at the end, we now have two people again, 42 to 44. That is, they are somewhere, they are telling you, they are giving the impression of outliers at the end of the day. So let's check this guy as well. We can only see one person. The rest is 0 as well. Okay, we have 44 here. we have 7, we have 11. So this one is still spreading across like that. So let's come to the employment length, and we want to fill the missing values. We want to also fill it with mean so that it won't still also affect our distribution a lot. So now that we've done that, and as you are doing those operations, you can see it here that all the operations that we are doing are coming here. We can just come back and delete it and go back to the previous state. So once we're done with that, let's try to add it to our notebook. And what that one is going to do is that it's going to show the code that was used. A code will be automatically generated um, by the Wrangler to just remove those things that we don't want in our data set. So this is where we have the code that you see here is saying that code generated by Wrangler for pandas data frame. So what we are trying to do here is that the operation that we did here, the code there has been generated. So if we don't run this cell, nothing will happen. So let's run the cell and see what exactly will happen. So we are trying to run the cell. Now, you can see immediately we run the cell. Don't also forget that the Wrangler has renamed it from df no duplicate to df no duplicate clean. So which is a little bit tricky. So we can, before we run the cell, we can as well just change the name before we even run the cell at all. So let's just leave it like that. We are just trying to remove duplicate. We just use Wrangler to remove it. Now let's now come here again and rerun the same code that we have up here and see if it has been applied to our notebook. So let's print it again. It's not going to be df no dupe again. It's going to be df dupe no dupe clean. So let's run it and see what will happen. Yes, so it's still running. Now we can see if you look through our data sets now, we don't have any of those things that are missing again. We just use Wrangler to do it very efficiently. And then we could have gone through the route of plotting graph, a lot of graph to preview our data and all those kind of stuff, which is why I tried to hide these cells from us earlier. So let me open one of these cells. You see, these are the things that you could have easily seen if you pay attention to it in Wrangler. You could have seen all those things in Wrangler very easily. So all this kind of chart, all those kind of things, Wrangler also help us to take care of that very efficiently and very fast. You see, these are a lot of code that I wrote to do those operations that I just did in Wrangler very easily. So let's pay attention to that as well. That's one of the power of Wrangler. It tremendously reduce your working time in data exploration. Now, let's now say those two things that we saw earlier, the higher age and all those things. Let's explore, let's understand what is happening there. The reason why we are doing this exercise, this particular data exploration like this, is that so that we will know that our data, our model is heavily dependent on data. Anything that we didn't pay attention to, that we didn't give that concern or check, is going to be affecting our model. Our model is as good as the data that we put inside. So now let's try to check that particular column that we are trying to do. So now let me add a new cell. Yes, so I want to add a new cell to investigate what is happening in those two stuff. So now let's come here and say df no do clean. So here, what do I want to check? I want to check for the people that I'm coming. So let's check. We want to check people that have employment greater than 70. Let's start with those ones. So let's try to say df, the column is person employment length that is greater than 70. So 70. Now we can wrap it again inside index. so that we will see all the column. Because if you run this one, it's supposed to just create a series for us. If you have watched that video that I sent on YouTube video, all those kind of video that I sent in pandas, you could have seen it. So let me try to run this. It's going to give me a series. It's supposed to be a series like this. So now you see it's giving me a lot of series, true, false, 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 false. This is series. But to give me data frame, I just need to wrap it again inside another df node do clean. So I just want to wrap it inside another index block. So yeah. So this series that I have here, I just pass it inside another index. So it's coming on to load it now. So we can now see it in data frame. Now it has filtered out all the one that are false, 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 false. It's only bringing the one that are true now. That is where the column of employment length is greater than 70. Those two guys that we mentioned, because our Wrangler showed that is even two. So this shows that we are on the right track. Now we can check these two guys. We see something like, okay, this person's age is 22. This other person's age too is 21, right? Now let's check further. But the employment length that we used to do it. So the two of them has 123 years of employment. How could it be 22 years old and have employment length of 123? So that's really something that is probably wrong. Maybe they want to put in something there or not. So here again, you could have replaced this figure with mean as well. You can write code to replace it with mean, or you can go to Wrangler and replace it with mean as well. But let's assume that your decision now is to drop these two guys. So how do you drop them? So we can easily rewrite a code where we can drop these guys and say, so let's rewrite the code and just put, let's say here, df, okay, so that it won't be there. Employment greater than 70 years. Now let's add another code block. And then we want to remove them greater than 70 years. So we want to remove them. To remove them, we can just write df, df. This my network is really hanging the workbook. So that's why I'm going back and forth. So df no do clean. Now, I will now say dot drop because I want to just remove some column. So index is equal to, where do I want to remove? So I want to remove it from where the employment is greater than 70. So I can just come up here. Let me just copy the code above here. Okay, and put it inside here. So there are different ways to drop in pandas, but this is one of the way that I am very cool with. So we can still come here and do in place. Anytime you are doing in place, is just that make sure that you go to the data set and replace it. If not, I would have defined a variable as well and say df no do plain is equal to this. So let's try to run this and see if it's going to work for us. Yeah, so it has removed those guys now. So let's come here and then copy this code again and verify our logic if those guys have been dropped. So let's try to put them here. Yeah. So let's check. You see, now we don't have any information about them. We have used this particular place to drop them. And don't forget again, you can use another method to drop. So this is one of the methods that I am very familiar with, choices. Now that we've done this, let's try to even check our data set again and see how those things look like. I'm coming. I think we saw something about age as well when we are in our wrangler. So let's check the age that are greater than, let's do, let's start from 40 and see, or maybe 30, anyhow. So I'm going to remove that. And I want to just see age that are above 40. Yeah, so want to see, okay, it's telling me DF no due greater than, oh, let's check. There's no column called age. I think it is actually called person age or so. So, sorry, let me write person's age. Now we run it. Yeah, so we can see the list of people that are greater than 40, 45. I think this one is cool. Let's now check. A lot of people are here. Let's check 75, for instance. Maybe that one too can. Let's check 75. Yeah, you just have how many people here in 75, um, 80, 84, 76. Yes, these people are very short, people that are above 70. So if you want to consider removing outliers from your data set, you can remove guy on 94, 84, 80. You can remove those one. Even everybody that is a subject of removal. If you don't want age to be affecting your model like that. But let's leave it there. There's no harm. Um, now that we've cleaned all the data sets, let's just visualize our entire data set again. Because this is just an iterative process, you will just be going back, going forth again to be sure that you are doing it the right way. So this is what our data set is going to look like. We have all our columns, everything like this. We'll be pointing back to this particular output as we move on. So let's proceed. Since we don't have much to do in the cleaning, um, now what we can now do is that we can now, before we go into the next step, since our data is clean for now, the next thing for us to do is that we want to start preparing our data. And one of those things that we talked about last week when we are trying to prepare our data is that fundamentally, machine understands numbers, not all these categorical columns that we are seeing here. So all these categorical columns that we're saying, own, mortgage, all these ones that we're seeing here, we need to find a way to bring them back to numbers. So once we bring them back to numbers, there are ways that we do all those things. And then I will explain the concept, what used to go through my mind anytime we are trying to replace these things so that we won't just miss it out. Anybody can just come here, type the code and say, you know what, let's just do it this way. They call it encoding. We want to encode these columns. Person's home ownership, this first column here, and then again as well, this column right here, loan grade as well as this one as well. So the rest are numbers, so we don't have any issues like that, even though we are still going to touch them. So the first preparation we want to do is that we want to convert these guys to numbers, not this one that they have. Now, to be able to do that, what I always do is that let me explain what encoding is all about. Let me stop sharing this part of the screen, and then I can use my maybe something else to explain, maybe draw something to explain what you want to do. But that doesn't matter. So let's just be, let me stop sharing this part and go to the meeting and share my entire screen this time around. Yeah. So I want to use, okay, I'm coming, allow. I want to use a tool that will allow me to draw on the screen so that I will be able to see what I want to explain. So what we mean by encoding is that the first way we always do it is that we can come to this column and find a way to change. Since we know that the variable here, they are just four, we can start with, if you see own, write 0. If you see mortgage, write 1. If you see rent, write 2. Or the four of them, we can write it in code and say the first value should be 0, the second one will be 1, the third one will be 2, the fourth one will be 3. So we can encode it like this and do this. Another way that we can do it for the loan intent as well, we can say education 0, medical 1, venture 2. So those are the ways that we can encode, and we can just come here and write it in code. So we can come here and write it in code. Let's say we want to do something like, let's say dev map values. So we can now say we want to put in something inside this place. This is the normal way that some people used to do it. You will now say if data is equal to mortgage, you can replace it with 1. Else, if it is this, replace it with 2. Else, if it is this, replace it with 3. Why that can work? That can actually work. If you use this method to do it, it will work. And you can also use data wrangler successfully to do it. But there are abstracted libraries that do all these things for us, encoding libraries. So to now do that, let's come here, and then I want to pull up a notebook quick so that I will be able to, I will be fast with it. What I always like is that in that kind of scenario, yeah, so this is what I was explaining earlier. To generate all those things that I visualize in Data Wrangler, these are the code that I used to write it, to just see the percentage of people that are owning house and all those kind of things. But with Data Wrangler, I can easily see those things. But moving on to the one that I was trying to do, which is encoding. So let me come up here. These are just charts that we have seen in Data Wrangler. Imagine all of those codes above. We are now trying to write it one by one. It's going to take a lot of time. I think the other one should be able to do it. So I want to get a data set where, yep, here. So what I did here was this. I already understand the problem that I want to solve, and I group those data according to the operation that I want to do. So now let's come here. Yeah. So that kind of operation where we want to replace it with 1, 0, 2, 3, and all inside the same column is just ordinary type of encoding. So the other type of encoding, which is OT1 encoding, is that what we will do here is that, you know, this particular row 1 now, it is having own, and let's say it is 0. It's not just going to list it 0, 1, 2, 3, and all like that again. It's just going to create another column here and say the value here, is it own, is now going to turn it to 1. That's another column. Every other thing that is not mortgage will be 0. So the column will look like this. Mortgage 0, because that one too is rent, 0. Another one is rent. Until we see another own, it will become 1. That is for OT1 encoding. It will create a new column entirely. So let's call it new column. So after that, it will now create another thing, another column again, and say, you know what, there's another column here because there are 4 values. It's going to create another one, which is new column again, but it's for mortgage. So it's going to create that one and say, let me come down. Okay, so let's come down to, so it's going to say, okay, this first row, is it mortgage that is there? No, it will replace it with 0. Then we'll have here, we'll have 0 here. It's going to come down here again and say, in this second column, is it mortgage that is there? Yes, we are in mortgage column, replace it with 1. It's coming here again. This one, is it a mortgage that is there in row 3? It is rent that is there. So, and it is not correct, then it's going to come here, turn it to 0. It will do the same thing for all the values that are there, which are 4. So 4 new columns will be created. That kind of encoding is called one-hot encoding, like this, one-hot encoding. The other one that we're talking about is just um, ordinal encoding or categorical encoding. So now we need to understand the impact of all those things. If we use auth1 encoding, that means your data columns will be wider. And now the danger about using it inside the same column like 0, 1, 2, 3, instead of creating multiple columns, is that if there is no true relationship hierarchy between these data sets, you will miss out on what the machine is trying to learn, because it's going to try to establish a relationship between those columns. It's going to be like, okay, you know what, all of these 0, 1, 2, 3, they are related figures, whereas they might not even be related. Now, let's say we have something like education column now, and we have primary school, we have secondary school, we have tertiary institution. All those ones, they have something like an hierarchy. So we can replace them with 0, 1, 2, very understandable. But when it is data set like male, female, there's no hierarchy between male or female. There's nothing like all those kind of related ones. So we need to be trying to use auth1 encoding for those ones. So that's like the basic catch that is there. So instead of writing the code to do if this is this, else do this, imagine we have 13 variables. Are we going to write else if 13 times? No. What we can do is that we can just write code to do that. So since I already know the kind of operation that I want to do, now I just went to my notebook and describe. I don't want to be typing a lot of things here because of time. But if you are working on your project, you know you have to type it explicitly actually. So now I now said this is my column list. I list all the columns that are inside the data set. And then now I now come here, don't ignore the scale columns for now. Now, here, I just say OHE, the column that I want to do auth1 encoding on. So if you come here, I said in my OEE columns, let me try to, I think I missed out 10. So let's say OEE columns, loan grade, loan grade, home ownership, loan intent. The three of them, home ownership, loan intent, and grade. I want to use auth1 encode to do it. That is, come here, create a new column for own, create a new column for mortgage, create a new column for rent. The same thing with education, create a new column for education, medical. So I will have more columns here. And then I also define my ordinal column, which is this yes or no, 0 or 1. So that one, I just want to use ordinal encoding to do it. I could have just typed if else, if it is y, replace it with this. If it is n, replace it with 0, something like that. But we want to understand the concept of encoding in case you see it in the script. So that's why we are trying to use a lot of approaches. We've used data wrangler, we've used the normal pandas coding. Now we are going to explore auth1 encoding. So we've started our journey of data preparation now. So let's convert this guide to a markdown and say, okay, so and say data pre-processing or preparation. So pre-processing, yeah. So we want to do data pre-processing here. So now let's begin our data pre-processing journey. So to do this, one of the things that I will also advise that I would do initially is that try to split your data from what you want and then what you actually don't want. So now let's spell it out now. And I want to say df no dupe clean. This is the updated version of our clean data. So I want to set my x now into drop. So I want to drop a column. So let me now say columns is equal to, so the column that I want to drop loan status because that's my target. This is the column that I'm trying to predict. So I said, create a data set where there is no loan status there and call it X. Now, I also want to create Y and say df no dupe So no dupe clean. Here, I now want to get only the loan status. So let's come here. Now we have a column where we have two data sets now, where this column is not there, this loan status column is not there, and another one that is just only the loan status, which is quite interesting. So let's run this and save those things as our variable. We will see the reason why we are doing this kind of operation now, and the reason why we do the one that is up here. So let's run this one too that is up here. Okay, so I have my column like that, everything defined. I'm just trying to set the rule. Okay, so moving on, we now want to split this data set. We can split the data set before we do the encoding, and we can do it later on and stuff like that. So let's try to split and get our data clearly before we even begin to do back and forth to those operations and all. So now the code to do that, let me go and copy it to save time here as well. So I already write the code here. So let me come here. Yep. Now, I've on the workbook, there is sklearn already there, and I already imported it above. So here, I'm now just trying to split my data set, but we should be very careful here again as well. I've not done any operation so far. I was just trying to describe what we are trying to do. So here we have X train, we have X test, we have Y test and Y train as well. So what is going to happen here is this. You see, in Python, there is a way where we write a function, where we write a line of code and say, let's say we have something like full name, and we type first name, we now say comma, last name, we now say is equal to something like split full name. So, and then we want to split it by something like a comma. So what this one is going to do is that it's going to create, it's going to, let's say our full name is actually Bayo, comma, Oyetoro. It's going to create, it's going to split it based on the comma that I separated and say Bayo goes to first, and then last goes, Oyetoro come to the last. So this is kind of the same thing. Here, if you come here, I define 1, 2, 3, 4, 4 variables, and then I use this library to just split the data set and say, you know what, come here, split my data set based on this size, and then select it randomly. Don't pick it from 1, 2, 3, 4. Do it randomly, and then also put them like, split them like this into all these ones. The model has been, you can use your hand to, you can code it manually and split it manually if you want, but the module already has everything inside. Just split it into all of this. So I only specify my test size and I specify my randomness. So now I now say print the shape of X is this, comma, the shape of, so I want to, for each of them, X, I will have train and test. For Y, I will have train and test. So I want to match those things together. So now let's run the code and see the shape of each of every one of them. So it's telling me that, let's check the error that we have here. Found input variable is inconsistent with number of size. So let's try to check. Okay. So I think we just need to rerun this and see. Okay. I want to retrace the error where we're having that kind of error. Okay. Let's just check again. It's still bringing the error. Found inputs variables with inconsistent number of samples. So let's come here and then resplit it. So let me go to the code. Okay. I think the variable, let me rename the variable to something like y, maybe. Let me check up here and see. Okay, we only have y ones. Let me run it. If it's still bringing the error, yeah. So what I did here was that I noticed that my Y here that I put here is in capital letter, and then the one that is trying to work here is small letter that I put inside. So I just went back to correct it. So now we can see the shape of the X train. The data set has been split into 24,000 for test for training, and then 28,000 for test. So most of the time, we always want to train more so that we can the machine will learn a little bit very better than all those things. So we have our Y as well. Now we are still here to do those encoding operation. We are just splitting our data now. Let me come here now and apply the auto encoder and see what happens. So let me come here and add a new block of code. Yes, so normally all of these things would have typed it manually, but to save time, that's why I'm trying to copy and paste. I was working on it this morning. So now here, the syntax that you are seeing here is just normal, common for everyone. But what you just need to do there is that you just need to come here and specify the columns that we define up here. So now let's come here and then let me put the N. I thought I made a mistake when I was trying to write it earlier. So I import hot1 encoder from the module again. I now said that, okay, OEE, hot1 encoding, this is just a function that, okay, use hot1 encoder, don't pass, and unknown, ignore it. If you see any unknown, ignore. Then this syntax again is still also generic. What you just need to put there is that put in the columns, these OEE columns. Instead of typing the name of the columns out inside this place, I don't need to do that since I already defined them up here. So that's why I define them up there and put them inside. These are the ones that you just need to change. Just split them like this.
Hello, Mr. Bayo, are you speaking? Mr. Bayo, we can't hear you. Mr. Bayo, you need to check your audio again if you can hear us. We we can't hear you. Please check your audio and try again. Okay, thank you.
Okay, hello. Can you hear me now?
Okay, can
Yes,
yes, can
yes,
hear you
Mr.
now.
Bayo, I can hear you now. Yeah.
So I joined with my other device so that I will just continue like that. I will be sharing my screen. Then we'll move. So can you still
All
see
right.
my screen?
Yes, we can.
Is it on fabrics?
Yes, it's on fabric.
Okay, all right. So what I just did with that last operation was that it's going to take own, create a column, and anywhere it sees own, it's going to turn it to 111. The rest will be zero. You're going to take mortgage, put it beside it, change the mortgage to zero for this one, and anywhere mortgage appears is going to turn it to 111. For all the four variables, the same thing with loan intent, the same thing with loan grade. So we have a lot of columns right here. Now, the next operation that we want to do after we've done that is that we want to do our ordinal encoding, where we want to replace this guy with 0. We want to replace y with 1. So 0 for that, and then we can write it manually and just write the code manually ourselves. But just to show that we, and just to demonstrate that we can use other tools in case the manual coding won't work. So let's do, let me even print this X string for us so that we can see what we have now. So let me put in this guy and see. This is what I'm saying so that we can visually come in. So that we can visually represent see what I did. So this is the initial data set. And then now you can see here we already have multiple columns now for mortgage. You see, mortgage is only showing in column in row 4. That's why we have 1.0. Every other one is 0. It took others, turn it to 0. Where other shows it, we turn it to 1. The same thing for own, the same thing for rent. So we can see loan intent again. Loan intent too did the same thing. So we have multiple columns at the end of it now because of that auto-one encoding that we did. Now, and that's the sample. So we need to just remove these personal homes now since they've been represented with numbers at the back. So let me clear the sample that I just did to preview it. And then we come here to do the manual one. So let me do the ordinal encoding. Okay, let's do the manual encoding first. I'm coming. So we copy that part and then put it here. So I have specified my, let's check ordinal encoding columns. So I have specified my ordinal coding and column here. So it's just one column. I just need to come to the ordinal encoding here and just put it to ORD column and all. But since it's just one column, that's why I type it out. So let's try to run that and see what happens. Now that we have done that, so we've done our hot1 encoding, ordinal encoding. Those are the common two types of encoding that we have. Now, let's go to where we want to remove the initial ones. So let's come here, remove those initial ones that we have. So how do we remove that? We just come and specify the data set. Go to x.string, drop this column that are having that name initially. Because the new columns, they will have the name of the column and the name of the variable they used to generate it at the back, so it won't be affected. So let's print that and let's drop it and print it out and see how that looks like. So it's still running now. Now you can see those mortgage and every other one has been removed. Then we have this one now replacing mortgage, others, own, rent, debt, and others like that. So let's rename, let's drop the other ones too, I guess. So the reason why we didn't need to drop the other ones, if you pay attention to it, is that X train here, I just use the name of the column and describe a new variable like, okay, do the hot1 encoding on this column and replace it. So I did the replacement immediately when I was doing it. But in this one, I use a new variable. I didn't replace it in my data set directly like that. So that's that about it. The next, after we've just encoded our data now, everything is in numbers. So let's print our data set and see how all of it even look like. Okay, I think it's printed here. So let's check how it looks like now. So we have 0055. Everything is in the right figure. Yeah, everything is in figure now. So with the encoding, we have done that. So let's see the next operation. The next operation for us is now to do, let me show you the reason why I import this thing. So come in code and then here paste it. Yeah, so I want to check my Y train. All of these things that I'm doing here, before I can arrive at what action to take, I have explored. I have tried things. It has failed. I have come back. So it's always a lot of back and forth, which I won't be doing on the class. That's why it's appearing like, okay, this person crammed the data set, this person know the. So you need to do a lot of try and error before you arrive at what to even do. So when I was doing this, I said, okay, let me check my train data, the data that I want to train. So now I see that my loan status there. I splitted my data set into X and Y. So I want to focus on that loan now and see how many loans were even approved, how many loans were paid back, how many were not paid back. So when I was checking it, I could have seen it in the data wrangler, but I didn't focus on it. Now we can see 78% going for denial and 21% of them being approved. That means my data will understand more of rejection or loan that they didn't pay back more than the loan that we actually pay back. So this is an imbalanced data set. One of the ways that we can do this, there are different approaches to balance things up. Let's say we are trying to build a model for male and female, and you now have 70% male, 30% female. That's not representative. What you can do is that you can add more samples, balance it up to 70-70, or sorry, 50-50, or you can reduce the one that is even more to the same level. So the approach they want to use here is you can write those things generically with code, but there is smooth. We can use smooth to just do that. So that is why I pip install that smooth at the beginning and all like that. So this is just the code for smooth as well. So let me just copy smooth and put it here and explain what smooth does. So here in smooth, it's just telling me that, you know what, go to my data set. I want to generate a lot of data. Like it's just going to, it has its own approach and its own algorithm of generating those kind of data that it won't look too generic and it won't skew your data too badly. So if I apply smooth to it and I reprint my value, we will see what will happen. So almost all of these syntax that you are seeing here, they are just syntax that you won't even touch. That's why you don't need to focus on the code, just need to know what they are doing. So what we did was that we cleaned the data set, we encode it, and now we are just trying to balance it up. But now, if you run this thing locally on your PC, you are not going to see this experiment here. This thing, this runtime that you are seeing, anytime you see something like this coming out, anytime you see something like this coming out, it is an experiment. And that experiment that you are seeing here, it is just a log for you to track something inside Fabric. So it's trying to see that I'm doing some sort of operation that needs to be logged. That's why this experiment is generated. We will come to that when we are evaluating it, but let's just note the name. Magneta Luna is just automatically generated stuff. I could have write code again to log the experiment myself. So let's check what the smooth has done to our data set. So I'm trying to add more line now. Yep. So I'm trying to add more line. Okay. So let's check what the smooth has actually done. Let's try to print it again. Let's try to see what's happening now. Okay, my this thing is still coming. So let's do value because this is still y train, right? So let's just do something like s train value count. It's just going to count a lot of stuffs, but that doesn't matter. So let's just try to run and see. It's going to count a lot of stuff for us. So that's why but what happens is this. I use my y. Y is just one column, which is loan status, approved or not approved. So here, when I was doing my smooth, you see, I apply my smooth on X train, my X train sample. So it's the X train that was applied. So that's why when you print Y back, it's not giving you the actual thing. So what I did was that I used Y to get the information about my loan status that is not evenly distributed, and I use that smooth to just generate a lot of data set to my X. So my training data set now is not going to be 7821 again. They are going to be in the state of roughly 60-40 or 50-50. So my training data set now is going to be like that. That's what I'm saying, that is going to generate a lot, except you want to cram the name of that column and count one of it here. But we've even dropped that last column, so it doesn't really matter. So just that we use smooth to generate a lot of data to balance this number up. So the next thing we can do is that there's this scale as well. Now, let me clear this output so that it won't be interfering. So the first operation was encoding. Now we want to look at standardization. So what standardization means is this. When you are trying to pull up, let's say you are trying to draw a graph for data now, and then some figures are like 1,000, 1 million, and inside that 1 million, 1,000, you have some figures that are like 30, 40, 50. They won't show on your bar graph, for instance. They won't even show at all. You will only see those big figures. So what you can do is that there is a way in machine learning that they standardize this thing. The range will not pass 0 and 1. And the difference, the distribution is still going to be maintained. You know, if I say my data set ranges from 1 to 1,000, and I now consolidate it to 0 and 1, there is a gap between 0 and 1,000 initially. So I'm now bringing it back to 0 and 1. How does that make sense? So it's just going to be like, once you use that normalization method, a pre-coded syntax that is going to generate, is going to make the range between 0 and 1, and is going to maintain that distribution that they actually have initially. So that's what standardization does. If I come here, you see a lot of them are inside the sklearn module. So you can just visit their website to know all of this code were written and all like that. So here, you don't even need to do much again. I'm just defining more variable as we are moving on. So let me come here. So what I did here was that I said my standardization scalar. So this one we have different type of standardization. We have min and max, we have standard scalar. So min and max is just like make the range not pass this. We also have some sort of other standardization method. So in here, we didn't use min and max. So we just use standard scalar. So standard scalar is just going to reconsolidate it again, make sure that that range is maintained and the distribution is not broken. So that's what exactly it's just doing. And then what you just need to change there is still not much. Declare the variable, copy the syntax, just replace this, you see, X trained, sampled, X trained, resampled, or columns. So this one is just going to get the column name. So what I just did there is not Once you see the thing syntax, you will easily see what you're supposed to replace. So if I run this standard scalar line of code now too, it's just going to go and standardize my data. So I'm just doing smooth. Sometimes if your data set has 50-50 or 60-40, you won't need to run this code. But if it is now not balanced, you use smooth. After you use smooth, try to standardize. You can use min max. So instead of writing that way, you just write min max scalar instead of standard scalar. You just see min max scalar. So you are trying to configure the range of the data to be 0 and 1. So those are the basic two major operations that always happen, that is like almost black box to anyone that just wants to start. Or if you've worked on it over time, you will see that, okay, it's actually not black box. It is just you trying to make sure your data is ready. That's why they call it pre-processing. Another stuff that you can do is that, let's say you have some co-linearity in your data set, for instance. Let's say you are trying to predict something based on another thing. And then there's another column again that depends on that variable that you are using to determine that column. That is, two columns are depending on each other to get a prediction. You remove one of them. And how do you explain that kind of things? You need to print, let's just say, just type correlation, and you will see that, okay, these data sets, some of them are actually heavily correlated. I'm trying to look for an example that can make it so simple. Okay, so now let's now say I'm trying to predict somebody's salary. So, and then I am seeing like people that are education status now, and I have another one which is let's say where they are born. Where they are born, let's say where they are born determines their education status. People that are born in one state, they are highly educated. People that are born in another state, they are not educated. So that is like the state, the education column, education status column is depending on the state of origin. Then we can remove that state of origin or any one of them that I want to remove. So that's one of those things that we also do in data preprocessing. Um, Another, I'm still trying to think of another preprocessing operation that we can do is that, let's say you can even do operation like multiply two columns to get a new column. You know, the way we do sales, and then the number of orders, we multiply them to get the revenue. So you can consolidate 2 or 3 columns together like that and get the revenue and use the revenue to make a prediction. So all those kind of things are part of the processing stuff. Then after we've done the two major processing, standardization, and then now it's now for us to now train our model. So this is another black box for beginners, but I will explain what the model means. So let's try to say, what do they mean by model? So far, all what we've had is just a lot of numbers, a lot of data sets called X-trained. We just splitted data and we just encode them to numbers. That's just what we did. But now, we now want to do the actual training. We want to train our model. So what happens is that you need to know some of these models before you even be able to pick it. So let's start with normal logistic regression. How we always come about it. Before you can pick a model, so before you can use data to do, let's say you want to build a model like this, select any model. There are a lot of algorithms, there are a lot of models, and they work. That's me. Somebody wants to say something. I'm checking my chat. Okay. I'm sorry, please, can I continue? I'm hearing some background. Okay. So here, let's say I have I just want to list some algorithm now. So anytime if you are new to this, you just need to go and read some algorithms in machine learning. So there are some algorithms that work for classification tasks. There are some algorithms that works for regression tasks. There are some algorithms that work for um, let's say what are that of clustering tasks. So now let me
That's
come
fine.
here. Yeah. So let me come here and show something here. Yeah. So in my screen here, normally the linear regression work in such a way that, let's start with the simplest one, is what I consider the simplest. So what happens here is that, let me bring my cursor here. There is going to be a lot of data points here. Let's say there are a lot of data points here. And then you are now trying to draw a line in between. The moment you draw that line, what you are trying to do is that you are trying to say, where is that line that if I trace it up here, let's say I have a straight line, let me just bring in and insert something, because this is one of the important parts of the whole machine learning, not the coding part. So let's say I draw a line like this. I have a lot of data here. So this line that you are seeing here, it is my model. That is just what everybody is looking for. That's my model. And then what it means is that, let's say all my data point is around this range, and then new data is now coming up here. What I will do to predict that is that I just need to trace it to this place and trace it down, and I will predict the value. Let's say hours of study now, for instance, new one came here. I am just going to follow that line, which is my model, and trace it up and say, for that person that has hours of study up here, the person is going to be here. That is linear regression. It is used to predict, what's it called? It's used to predict continuous variables. Now, in logistic regression, all these data points that we are seeing here, all these data points that we are seeing, this logistic regression, what is going to be doing is that, let's say I say somebody study for 20 hours, 30 hours, 50 hours, and I'm plotting it against pass or fail. You know, it's just two things: pass, it is fail, up. So it is just a very different data point, not all those ones that will be around literally everywhere like this one. So it's just going to be only one straight line and everything like this. We can't draw one line and say we want to be using it to predict. Now, what we need to do at that point in time is just to apply a non-linearity function, a linearity function, which is sigmod. So if we apply that function, that's math. That's why I don't want to go through math explanation now. So what that function is just going to do is that it's just going to draw the line of best fit for those kind of things that you did, for those data points, and is now going to put a threshold there and say, you know what, if that data set is above this threshold like this, put it as, let's say a data point is here now, it's going to be like, put it as fail. If it's below this threshold, put it as pass. That's where that machine learning is going to be predicting. Another algorithm, that is logistic regression that I just explained now. Another algorithm is this. Let's just have a closer look at KNN. They call it K nearest neighbor. This is a lot of data set that was inputted into the machine. So somebody came, this is the height of the customers, this is the weight of the customers. So they have a lot of height and weight. So people here, their weight and height is in this range, and their weight and height is in this range as well. Now, they now want to build a model. So that model is just going to be like, this place, we draw line. We build a model, a line. But in this K nearest neighbor, we are not even going to build any line. What we are going to do is that it's going to bring the new data point, which is this green line, and put it here. Let's say the green line is here. The person's height is around 155, and the weight is 65 kg. And it is here, it is trying to predict if the person will wear small size or large size. What it's going to do is that it's going to measure the distance between let's say this is the closest one to this green in this data set. Now, in this first group, it's going to just measure the distance and compare it with this one as well. So closest one, that is what it will predict. If it is closer to small, it's going to say this person will wear small. If it's closer to this one, it will say the person will wear large. So this one now is now like the nearest neighbor that you specify. I just consider one here, one here. That is the number of my K. If I specify 3K, it's going to check three nearest neighbor here, three nearest neighbor here, and use it to and write the average distance and use it to group my model. So you see this one, we are not really building something very complicated. And the last model that I will use in this place is let's also explore support vector machine, SVM. So now you see what this one will do is that these are data points again as well. The person's age and then their savings. You want to check, okay, this person we let's say pay back a loan or not pay back a loan. So, and we have seen a lot of people in this age bracket in this place. And we have seen a lot of people again in this age range and savings range. Now, what is going to do is that the last person here in the first cluster and the last person in the second category is going to compare them and use it to build a line of the extension, which is this one. So these two lines that you are seeing, these two guys that you are seeing here, let's say these guys that was compared to use to that we used to draw this line, they are called the supporting vectors. So this one and this one are the supporting vectors. But you see that one in straight line, this straight line model is our model. This is our model that we are seeing here. Anything that is now coming, let's say the new data point is around here, is just going to group it into this other category. If our new data point is here, above up here, it's just going to check, does it fall over the line or here in the line? So that's what the machine learning is trying to do to predict. That's why it's very important to, and then it's always very important to understand how this model works so that you can pick the right one when you are working on some things. Like, for instance, now, let's say you are trying to consider and analyze this report that you are seeing on my screen now. I designed it when we are trying to do a problem in my organization. So I analyze a lot of model for that kind of operation that I want to do. And I pick the best one based on the way they work fundamentally. And then I will also explore the performance metrics later. So let's leave it as this. So these are the way the three models that I want to use work. Now, so let's come back to the code. So we want to train our model. What we can now do is that the syntax to do the model too is almost the same thing. Now, here, this is our what's it called? This is our code that we use to train logistic regression. To do logistic regression is just like I think 8 lines of code. It's even just 2. These other ones are just to 1, 2, 3, 4. It's just 4. But these other ones are just to print the outcome and see exactly what we have. But to do that, if you just train your model, you are going to have that line. But at the same time, you don't know how your model is accurately doing that task that you asked it to do. That is where confusion metrics comes in. Confusion metrics is like one of the most important stuff that they use to evaluate a classification model. So let me try to delete this guy so that we can see what confusion metric is all about. Okay, so let me try to just bring it up like this. I think this is too big. Yeah. So now this is just confusion metrics. What is happening here is that we predicted some values. We have yes, no, that is our prediction outcome. In this place, we have our reality. Was it actually yes? Was it actually no? I want to explain how the performance metrics work now. Now, let's now say for this guy now here, our model says that this person is not going to pay back our loan. In prediction, our model said, let's say the person is not going to pay. I want to do it in a very positive way now. Let's say the person will pay back loan. Let me type it here and say, let's type it here. let's say pay back is yes, not pay back is no. So that is our prediction now. Now, let's say the person, our model said, you know what, this person is going to pay back. That is yes. We have something here. And in reality, the person actually will pay back. That is also yes. That is true positive. That is our model predicted correctly. The person is going to pay back, yes. In reality, the person pay back, yes, that is true positive. Now, here in our prediction part, our model said the person is not going to pay back. But in reality, the person actually pay back. The model, this particular part is called false negative. That is, in reality, the person can pay back, but our model said no, the person will not be able to pay back. If you come to the second row, and let's say our prediction say, you know what, this person, he will pay back, but in reality, the person didn't pay back. That's false positive. That is, the person will not be able to pay back. Now, in the last one, the person wants to pay back. The model said no. In reality, the person didn't pay back. That is true negative. Now, for our model to be accurate, to predict everything correct, this is the only correct spot, and this one is only correct spot. When the model prediction is yes and the reality is yes. When the model prediction is no and the reality is no. Those are the two things that we aim to achieve in our model. But you see these two guys, these are negative. When our model predicted wrongly here and also predicted wrongly here, these are the two things that we are trying to avoid. Now, this, based on this fundamental, those are the things that they use to generate accuracy. So the first thing is, how accurate is your model? That is, out of the prediction made, what percentage is correct? Now, I already said it earlier that the only correct spot is this place and then this place. So these are the correct ones. We will now add the two together and say where we are correct divided by the entire prediction that we make. So formula for accuracy is now TP plus TN divided by the total number of observation. So that is accuracy, how accurate your model is. If you want to do something like, let's say, precision, that is, out of all the yes prediction, how many of them were even correct? So the thing is just that we only don't use accuracy to measure these things. We want to use precision as well. So now let's come here and see it. This is reality. Yes, this first line, this is reality. But now when we now want to do precision, precision is now going to be like, you know what? These are the predicted value that are yes. How many of them is correct in this yes? That is why you see the formula for prediction is, this is when our model is correct, TP divided by TP over FP. This is this is yes prediction. Our model predicted yes here. In reality is yes, in reality is no. So out of that prediction of yes, how many of them were correct? So we're just going to take where it is correct divided by the summation of these two. So this is precision. Recall, on the other hand, is that how good was the model when it was predicting events? So we already know accuracy, how many of them were even correct. We already know that how many of that yes prediction, how many of them were even correct, because it could predict more TP or less TN. So now to do recall is just going to be like, you know what, this is my true positive here. If I now divide it by these two here, how many of them, this is reality. That is, how close is my model to reality? This is reality of yes. how close is my model to the reality of yes, that is this TP out of this two that we are seeing up here. So those are the common basic one that we use to do recall. And then we can also check for the same thing for other one, that is in reality of no. In reality of no, how did our model do? So the reality of no is this, how well did our model do? So those are the kind of things that we used to consider when we are measuring the performance and then all those things. And the table that I just showed now is called confusion metrics. So that is why I will now build a confusion metrics to just be like, okay, anytime you run a model, I should be able to print that confusion matrix and see what happened. So because of time, we will build just one today, which is logistic regression. And then last Saturday, we will now build the last 3 models that we want to use and explore their performance and monitor them. Hopefully, we just deploy them. Let me paste this guy here. So let me run the confusion matrix. Then, oh, it has been disconnected. So it's trying to connect again. Let me try to hit standard connection. Okay, I think I was okay. It's still trying to not connect. So, so for you to connect, I think I need to actually now go back and run all the cells again, which is really going to take more time. So while it's waiting, let's just copy the code of logistic regression and see what logistic regression is all about. So logistic regression is here. Now, this one is just me trying to test before remote and then after we do smooth and all those things. But normally, this is just the code. What I'm changing there is that when I did smooth, I give it a new variable. I just try it on that 2 data sets. So let's copy one and put it right here. Okay, it's still trying to. So it's still running cell 1, trying to build that connection. But I think it's my internet that is very unstable. That's why we're having that. So, but for time's sake, let's come here. Now, when I run it in my environment, here is my, I think I have it somewhere here. Let me check down. Oh, I think I really don't have it there. Okay. I'm trying to check. Yeah. So this is where I ran it. Okay. Yeah. So this is logistic regression. So let's try to understand what happens here. This is what I did. So in the logistic regression, I just put this is the model training. So you need to just specify the randomness, even the default one. I use the default one, which is 12 and 1000. So what I'm doing here is that the randomness in the training, I set it just to what I want. Those are hyperparameters that we can tune later, but we are yet to get to hyperparameter. So here, I wrote the code for my logistic regression training. Then I just put in my parameters, Y train, X train. Those are the ones that are important to us. The model will do his work, train and do all this stuff. My next job is now like, okay, you know what? Use this guy, print some accuracy on them. Let me see the accuracy on those data that you actually did now, because the model is going to train and test itself. So now let's see what happens. As I now build the confusion metric here, you can see that my model is saying that in reality, the person with default is 0. Now we have, let's say, this is our reality now. Reality means that the person defaulted. And then the model predicted that the person will default true. Then we have 5,700 of them. That is, our model predicted default 500 and 5,779, which was correct. But the ones that will default, that our model said they will not default, they are 472. Now, again here, in reality, the person will pay back. Our model predicted that the person will not pay back. That is 1,000. In reality, the person will pay back, and our model predicted that the person will actually pay back. That is 700. We can see that our model is doing better when we are predicting people that will not pay back than people that we actually pay back. That should be telling us something on when we are dealing with our data set. So to now calculate the accuracy, our model was right in this place, predicted no, and then the actual is no. Predicted yes, and the actual is yes. So our model was right 5,799 times plus 726 times divided by the entire prediction that the model made. So we come to the, if you do the math, you are going to see accuracy of 81%. So using logistic regression on this model, we have 81 accuracy. Yeah, 81 level of accuracy. The other one to recall precision, you can do all those ones and get those figures. So that is how we build up the model training and then the performance analysis. So let's now assume that we now want to now try a lot of experiments, because in this place, this is where we try a lot of experiments and see what you really want. Let's say you are building a model for a clinic. What will be your interest will be different from when you are trying to do another stuff. So let's say in clinic now, you want to see if the person has HIV or not. This person has HIV or not. And your model is predicting that, you know what, this person don't have HIV and the person actually have HIV. Then that's a very, very bad scenario. But if you say the person don't have HIV and your model say the person has HIV, that's still reduced, but it's wrong. But it's reduced compared to when the person has and you don't see it. So the same thing translates to cancer. So cancer is something that you always want to not miss it. So at that point in time, you will now trade off between precision or recall or F1 score or accuracy. Which one do you actually want? Some people will want accuracy. That is, they just want to guess the number that they are right. Some people want to be like, how many times they are wrong. They don't want to be wrong at all. So you will now trade off between those things. So immediately you are removing your accuracy, you are doing hyperparameter tuning. It's going to be affecting those figures, but you need to specify which one is your interest. So in a doctor is not allowed to make mistakes. One mistake is killing one person. So in that kind of environment, you don't want your model to be making mistake at all. So those are the kind of things that so we now bring it back to loan. In loan, we don't want to be missing out on the tool, because our aim of doing this is that to really get profit. So do we want to say that we want to be correct when they will default, or we want to be correct when they will not default? So which one do we want? So you just get to decide those things and back it up when you are doing the documentation of your model. So that's what we did. Let's check if this guy has finished running. So he's telling us that session is ready. A lot of them didn't even run from beginning. So he's telling us OEM is not defined, OEM columns. So let me come here and then change this so that we'll be up to date. I think it's the end I was missing. So let me run it again. So it's run this time around. Here it will run. Okay. We apply smooth here. Let's check the last one. So it's trying to run. Let's see. Let's say it's doing. So we apply smooth here. It works. We standardize here just to normalize the range. It works. So now we want to do confusion metrics. So the confusion metrics works. Now let's do our logistic regression model and see how it works. So, but don't forget again here, this is another experiment being
Hello,
saved.
sir.
All right.
Sir. Mr. Joseph, hand is raised. I guess he has a question.
Okay. So you can go ahead now.
Okay,
Hello.
all right. Thank you, Mr. Bayo.
All right.
The class has really been impressive. I've really been learning a lot. Right. So I just wanted to ask, I don't know if you're still going to touch on it, but so far, from what I understood that you're saying is that you can either have it accurate with numbers or precision, right? Like if you want to know that for the ones that if the one that you run right now, can you please open up that IDE, the one that you
Okay.
were running the script
Same
on?
thing, the same thing is already in this environment now. Can you see it on my screen? This is the same thing. Or do you want it
Yeah.
in this code?
Okay,
Oh,
no,
sorry.
it's fine. I can use that one too. Right. So for this one now that you have 500 at 5,800 is the one
Mm-hmm,
that the model actually got it right. That, for
mm-hmm,
example, those people would default and they actually defaulted, right?
mm-hmm.
But below it, the 727 is the one that the model actually got wrong, right?
So
So that means
the
that
one,
it can.
okay, that 721 to sorry for cutting it, is also correct. For 5,800 and 721 are the one that are correct, because if you see in reality it is one, and the model predicted it is one. So you see that it's
Okay,
only 5,800 and 721 that are correct, while the rest are
yeah.
wrong.
Are
Mm.
wrong, right? So now you also made a mention of you can, as long as you are having a particular one that you are wanting, for example, people that will not default, and your model is actually predicting a high number of that. So is there a
Mm-hmm.
way to train the model more to actually get other aspects to correct, or once you have one, you're okay with that?
Okay, yeah. So yes, now that brings us to the question of, can we do that? Yes, we can. We can retrain others to make sure it actually gets it right. So now let me show a. That is why data science is always very tough and very challenging. Earlier we were saying that our data set has large number of people that are that didn't pay back. Let's say 70-30. A lot of data that we want to train the model with. A lot of them were zero. Now the model is going to understand zero more compared to one. That can be the reason why this metric is here, for instance. Now, to now do all those kind of things, we now need to go back to, like, say, if the number is really totally off, that this model is extremely doing well when we are doing prediction that are they going to pay back, is doing well. But when it's now coming back to are they going to pay back, it's not doing so well. I will now go and start by investigating my data first and say, does that data is there any imbalance there or something like that? Because it's performing well here and it's not performing well in the other. If I see my data set is not balanced, then I will need to reconfigure that. And if I rerun it again, I will have another kind of operation. Now, this model that we ran now. If you see my approach, I said logistic instance before we do smooth. Now let's see the operation when we actually do smooth. I'm coming. Let's try to do smooth. Yeah, I think I already did smooth in this particular one here. So here that I've done smooth, before smooth, after parameter, before smooth. I'm trying to check where I can compare them. Okay, this is before smooth. This one too is before smooth. All of them are actually before smooth. Yeah, so what happens is that after I did the smooth, I now rerun that analysis. You see this precision that you see here. So the first one was without smooth, imbalanced data set. But when I now did balanced data set, there is something that now changed. What changed is now like this. When I did my smooth, I now saw that it was performing from 5,800, it comes down to 4,000, which is still relatively good. But you see the performance in prediction that they will pay back is now improving because I'm already altering my data. I'm already changing my data. So as I'm changing my data set, you can see the accuracy level is changing, the precision level is changing and all. But there are more that we can do to that than changing our data set. This is where hyperparameter tuning comes in. Initially, before, I only use max iter and then random states. But now I can come here and use all this to improve my model. All of them has different things that they are doing. When we get to hyperparameter tuning, we understand all those things one by one. One of the things that I can do is that I can increase the training time. Let's say my training time is just like maybe twice. I can increase it so that machine will understand more deeply. I can also increase the training time. The time that is trying to use to do all those operations, I can increase it a little bit so that the machine will still also train better. I can even do penalty that if you get anything wrong, go back and relearn some things. If you all those things are upper parameter tuning that we can use to optimize our model. So it's not always like once we have this, you won't be able to do others. We can actually edit and then reconfigure to get what we want. Not exactly what we get what we want, but we can tune it and exactly get more about the data set. And then I think when we get to hyperparameter, it will become more clear because I want to focus on hyperparameter in the next session. That is where we undo model the other models, and then we'll focus on deployment. So those are the. I don't know if I answered your questions very correctly.
Yes, you did. Thank you. Then
Yeah.
you mentioned two things that we can do. We can increase the time and penalty. So in your code,
Yes.
please, can you just point out where you can do that?
Okay. You see this place, right?
Yes, like that's the penalty. I can see that.
So
Then for the
here,
time,
the training time too is not. I don't think I did the training time here because I was just when I was writing this code, I was doing a lot of tests. Like I was just testing over and over to see which approach will be better. That's what differentiates data scientists from others. So let's even say
Mhm.
this randomness here. You see, this is 649. This is not figure that I just put in my head or cram. I was just doing experiments until I get there. So if you see when I was
Okay.
starting and I only have random state of 12.
Yeah.
So here, I only have 1,000 here. So all these things in our next class, this is what we're trying to explain. What does mass ether means? How does random states, what does it mean? So that you'll be able to know which one of these parameters that you are even changing, which of them are you even tuning, and the impact on the data set. So I don't know if
Mhm.
that clarifies what you're looking for.
Yes,
Oh,
yes, yes. Thank you. Please go ahead.
all right, okay. So it's always like very serious also when it comes to training model because you don't want to so I work in the financial sector where if I build a model now and then they are taking a lot of loss because I bring a model that is not predicting very well. So from start, my line manager will already specify what they want. Please, we don't want this model to be making a lot of mistakes when it comes to they will pay back. He would have already told me that we don't want a lot of mistake when we want the model. Let's say we are doing small loans for small people, 30,000 naira and all those things. We might say that we don't care if they don't pay back like that. It's something that we can pay. We can cover the loss, but we want you to predict that okay, they will be able to do some other stuff, all those kind of things. That the performance metrics that I want would have been clearly stated by my boss. Then I will now come here and bring those logic to life. I don't know if I answered your questions correctly. Now, any other person here before we wrap it up?
Any question, please?
Okay, so I just want to also ask, so
Okay.
first of all, I'd like to thank you for a very job well done. I can this is a good class. Then also what parameters like for this example now that you used for loans, right? So what parameters are you checking for to determine if this person is eligible? Is it the salary? Is it the age?
Yeah.
And things like that?
Yeah, sure. So what happens is this. When I first joined the bank, so what we normally do is that I was having the idea that they call them features. Obviously, we are going to check those features, and then there's this something they call feature importance. Feature importance is where we just check the contribution of each of these columns to that result. That like we'll check the columns and check which one is more important. There is a solution for that in Fabric as well, where we can print our feature importance. We can even write it locally on our PC. So once we write feature importance code, it will just bring a graph and show all the columns that we have, and it will put the percentage of their importance. That is, let's say 70%, 10%, 2%. It's telling you that the contribution of this column to this. So, and then to really be able to say that this column, the example that we've been using so far is of like one feature, one prediction. But at the end of the day, it's not always like that. It's always about weight. There's a way they compute and calculate the weight. So it's going to combine 3 or 4 columns and use it to compute a weight. And that weight is going to be the one to determine our outcome. That one is really something interesting when you come to neural network, deep network, all this ANN that we are trying to build these days. But for traditional machine learning like this, the feature importance is what we guide you. Just print the feature importance. You will see which column is actually affecting your outcome, and you can go there and work more on that features that are very important. Let's say 5 of them or 2 of them, 3 of them. So in the next class also, we still print feature importance. I don't know if that also answers your question. Feature importance is the answer.
Yeah.
Like,
All right. All right. Then one other thing is how long do you think we time period, a week, a month, 2 months, a model should be trained before it can officially be used, for live decisions?
okay. So last model that we worked on, first of all, this is all these training model over time, one time, is always very good when we are doing projects for looking for jobs or the kind of one. You can build a model in a day, and you can deploy and people can be testing, since it's not used to make a live decision. But in an organization, first of all, to even train the model to get the data is so huge. We are talking about, for example, now the last model was using almost 20 something million rows. So that kind of operation, to even do it, to even load the data set to the environment and run it and do everything, we are spending like almost 1 week now, or more than
Mm.
that. To even get the data to get all your features, it might take up to 1 month. When you are now training, doing back and forth, testing, everybody is testing the approach, everybody is trying to bring their corner cases and all those things to the environment. Because machine learning, the bottom line is that it is not an actual stuff. It is based on probability and predictions. So that's why everybody needs to be trying crazy things to try to break what we build. So that one also can take up to like another 2 months or 1 month, because it's going to be
Mm.
like, oh, come back, try this, try that. If the person is having 20,000 naira and is not a salary earner and he paid before and the person didn't pay before, all those kind of things, all those considerations will take like almost 2 months. But the training itself is going to take like almost 1 month or more than 1 month. So by the time you are now finished and you are done, everybody will you realize some risk. Everybody will just like, okay, we are comfortable with this risk. Let's just deploy to live. Then you hand it over you write it out as a PQ file, PKL. Then once you write it out, you give the developers to consume, or if it's Azure, it's even very easy with Azure. So you give the consumer to the developer to consume. They will put it in the app and they will build an interface for you. You just come, instead of going through the bank and everything, just come there. The decision is automated, and you're done. So you have like almost 6 months. That kind of space,
Wow.
6 months.
Okay. All right.
Yeah.
All right. Thank you
But if
very
it's
much.
a lot, if it's deep learning, it's going to take off. Google deep nets, all those deep learning stuff, complicated ones, they take more time. Those ones are even more very, very, because of its data type.
Okay. All right. Thank you.
All
Thank
right.
you very much. That's
Thank
all.
thank you, Mr. Bayo. Thank you, everyone. Thank you for joining. We have taken more than, this is 19 minutes past 4. So I implore every one of us to join early next week, Saturday, when we wrap up on this training the model using data science in Microsoft Fabric environment. So I want to say a very big thank you to Mr. Bayo and to each and everyone that joined. God bless you all. The recordings will be made available to us so that we can fall back to it and go through it again